And for our last presentation in this group of presentations before the break, I'd like to welcome Mauricio Vergara, who's from ICANN's DNS Engineering Team, who's going to talk about the root server that ICANN operates.
Okay. Hello, good morning. My name is Mauricio. I know that it's really early, and I'm going to hold you for a couple minutes until coffee, so I hope it's not too long. I'm going to talk to you about the root server that is managed by ICANN. In a nutshell, the RSAC committee published in a couple weeks, probably a month ago, RSAC 026, with a lot of definitions and names that we're using on the root server systems. So we have a lot of new definitions, and we are outdated some names that we used in the past. So right now we define the root servers as an entry point of the root server systems, and is an authoritative name server for all the contents on the root zone. And what we're doing on the root server is basically following a lot of RFCs that we're using as our laws, or what we do and what we are not doing. So we have this comprehensive list of the things that we're trying to do correctly. The root server that we're operating in ICANN, it's currently operated by the DNS Engineering Team, which I belong. We're using the AS number 20144 to propagate our routes, and we're using those two addresses that we have here in our screens. We're publishing /23 and /24s on our routing system because we want to have the opportunity to bring out some of the servers that we have in the Anycast cloud. So if we have some problem, or we notice that we have strange patterns going to one server and we don't want to have them there, we can kind of use this mechanism with BGP to put the server away in terms of network topology. We have been Anycasted since 2007, and we have had two renumbers in the past few years. The latest one was on IPv6 last year, and we're still serving the old address, but we're planning in the future to stop doing that and deliver that net block to another root server organization so they can use it to use the same technique of the propagation of /47 and /48 if they want to, or to do some other experiments. I'm going to talk a little bit about operations and how we use our hardware and software and stuff like that. So currently, in terms of hardware, we have two different configurations that we're using on the root server. One are called the single instances, which are 1U server boxes that are being used by hosted ICANN partners. Those single instances, we're actually dividing those in three different hardware types. One are the old hardware that we used to say to the host that they will use based on some specific configurations. The problem with those was that sometimes one host will say, okay, I'm going to buy you this server so you can use it, but then the provider will change one little thing, like the write card or the Ethernet network, and some things will differ from one server to the other. So when this starts to grow, this is becoming a problem because we cannot actually have so much granularity control on updates and patches, and it's kind of a mess to administer. So because of that, we have two new server classes that are OEM hardware that a third party is providing for us, which is completely spec'd as we are defining, and those servers has already pre-installed the operating system to run. So in case that someone wants to have one of these root servers, they buy these appliances, which one is for like large kind of enterprise with 10 gigabit ports, or other that are smaller ones with 1 gigabit ports. So they can buy those, and we can start dealing with the software after that. And the other side, we have clusters that are currently hosted by ICANN in 3 different locations, on East Coast and West Coast in North America, and one in Europe. And those clusters are just like the picture that we have in front of here. They're composed with a lot of these single servers that are the OEM provided servers, and are capable to hold a lot of more queries. In terms of software, we try to have a lot of different permutations between different things, so we can not have an only point of failure, and have a lot of diversity in case that we have some sort of zero-day patch or some problem that we haven't figured out, or we are patching something while the other server is still working. So in DNS, we have NSD and NOT as to do different versions of DNS software. For the BGP part, we're using Quagga and OpenBGP. Our intention is to move away from Quagga in the future, probably going to BERT, since there is a lot of root servers that currently are using Quagga, and a lot of critical internet infrastructure on TLDs that are using Quagga. So we think that probably is best to have something different, so we can be more resilient to that. And in terms of operating system, we're using Ubuntu and FreeBSD. Our goal is to have a distribution of 50-50 between Ubuntu and FreeBSD, but nowadays we are mostly Ubuntu. I will say around 70-30. But we would like to have something in 50-50 sometime from now. As you might know, we're trying to use the geographical diversity provided by ENICAS and all the BGP that we can use, just because of the usual things, to put service close to user, lower RTT, how to be able to increase our query capacity, and to reduce the likelihood to have attacks. So also it's more useful for us to add or remove instances or servers from the specific locations without service degradation or interruption. Right now, as you can see, we have the following map of the locations that we're using right now for the root server. And this is aggregated by city right now. So Roy named before in the previous presentation that we have a lot of servers, but we try to use the terms instances, where we can have more than one server appearing with one AS number. So that's what we call an instance. And I think that right now, if we count instances, we're around 150 plus instances around the globe. Some sites have more than one server. So that's why we use that number. Since we have a lot of servers and a lot of instances out there, we need to have a better way to understand what is going on. So because of that, we're using a lot of measuring traffic and statistics, different techniques to do that. The first one is DNSstat, which is a software formerly known as Hedgehog, which provides near real-time statistics for the root server instances that we are managing. This is kind of a fork that from the software DSC that most of the DNS industry have been using for a while, but it presents some challenges for us because of the amount of servers that we were using. So at the current time, we're still using the capture engine that DSC provides, but the presenter is using DNSstat to represent that on a better way. And it has all the same features and functionality that you should expect, like the query types. You can query for attribute segregation, IP version protocol, and all the usual stuff. You can use it live with a little bit of delay, because we don't want to encourage people to try to test what is going on if they try to do something evil. Currently, we're using version 2.3.0 that was released on October last year. And we're looking forward to have a new collector in the future, which will be able to gather more data. This software has been funded by ICANN and is currently written by the people from Synodon. And they're going to speak later about CBOR. And if you want, you can access to the community open source software through DNSstat.org, where you can have also access to the GitHub repo. That this is a small screenshot about how the software looks nowadays, between the difference between IPv4 and IPv6 on a normal day. I think this is about last week. Since we have a lot of servers out there, we need to have some mechanisms to identify each one of the nodes that we have out there. So we have a lot of tools to do that. Besides the usual things that people do in DNS, like the hostname.mine or the id.server or NSID, which are currently standard on most implementations and most people working on DNS. We also have this RFC that we describe a lot of techniques that we're using to name all the servers that we have. So if you ask for a TXT record for identity.lrootservers.org, you can have information about the server that is close to you. And if you ask a dig query to node to lroot.server.org for the TXT record, you will have a list of all the active nodes that we currently are serving. For monitoring, we're using a mixture between external and internal monitoring. For external monitoring, for the DNS part, we're using Thousand Eyes and DNSmon, basically for having a better look of what's going on. BGPmon to notice if some route is being propagated or someone is trying to hijack our prefix or our AS number somewhere. And for internal monitoring, we're using tools like Zabbix, Icinga, and the same DNSstat and Expose, and a lot of custom scripts that we use on a daily basis and that send us a lot of emails, or we can use to query all the servers. So if you're interested on hosting an instance in your network, and especially if you are an ISP, these are the kind of the steps that we are asking right now. The prerequisites is that your organization is willing to host one of these servers. You will have to do some paperwork in there to sign NDA and ICANN agreement, so we can specify who is in control of which part and that's very explicit. You will have to purchase this hardware appliance that is specified by us, and then provide a housing for the appliance. That means that have the hosting, the power, the connectivity for V4 and V6, and be able to peer a BGP session with us with the aforementioned AS number. So if all those prerequisites you can do it, the workflow will be like you can contact one person on the global stake and engagement representative for your area that ICANN has currently one for each region in North America, Europe, Middle East, Asia Pacific, and South America, and Africa. So they will help you to get through all these paperwork on all these kind of steps that you need to follow. Once you sign the NDA, the contract, and you have the hardware, you will have to fill some information, some technical information about what IP number it's going to have, where it's going to be hosted, and some contact information in case that we need to reach out to you or you need to reach out to us. And once all the documents are executed on both sides, my team will take over and it will install the server in about probably 1 hour. Currently, the DNS Engineering Team it's part of the ICANN IT department. We are currently distributed in 4 different time zones. This is a thing that we elected to do because we want to have someone awake on their natural clock to see problems that might happen on different time zones, so you don't have to skip shifts or stuff like that. So it's follow the sun mode. And the team goals that we're having currently on our team is that we try to provide DNS expertise and excellence both to the community and inside ICANN. We're trying to strengthen the diversity and growth of the root systems service worldwide, establish collaboration within our peers, and trying to have the best engineering process that we might achieve. So also have some transparency and the documented process, not only internally, but also help to the outside community. So if you want to contact us, well, I'm going to be here until Monday if you have any questions, but if you want to reach out to us, you can find us on the usual meetings like DNS org, on the network operations meetings like NANOG, LACNOG, Center, OSNOG, on ITF. Someone will always be from our team. It's going to be in one ITF. We participate on different mailing lists, even when sometimes we're only looking and we're not commenting very much, but we're going to have an eye there. And social media, the website dns.icann.org, where you can see a lot of the information that I already show you, and on Twitter, if you want to reach out to us. So I think that's it. If you have any questions.
Hi. My name is Nurul Amin. I'm from Computer Emergency Response Team. Actually, my question is not directly to DNS implementations. Last week, we were handling some incidents related to prefix hijacking, BGP. So in a couple of slides, we were mentioning about BGP monitoring and BGP extensions. So I just want to ask, what is the status of BGP sec implementation all over the world? Whether ICANN is having any role in BGP sec implementation?
Yeah, well, our team currently, we are not using nor BGPsec nor RPKI to do any of these
because,
things.
In other sections also there is no reference to BGPsec or BGP.
No,
so,
no, because
so
we're currently not supporting that. We can talk on base-to-base if one host is willing to provide that. but currently we're not using it.
Okay, thank you.
Hello, Giovanni Modas, IDN. Thanks for your talk, very interesting. I'm particularly very interested in NKS deployment and engineering. So I saw that you guys use on Arrowroot different types of servers to cluster in the individual servers. And the way the NKS operates is that you don't get to choose where your clients are coming to, meaning to which NKS sites they will be ultimately reaching. So my question is, I know you have a lot of over-provisioning because of the DOS and et cetera, but how do you get to choose where to place the different types of servers or which locations you're going to put the cluster or not, or the different location?
So
from the engineering point of view.
So if we want to deploy some server, like our goal will be like be peering with every single AS number that exists. That will be like our main goal, like or which string. But we know that's not feasible. And the thing that we try to do is network engineering about how to route things when we are under stress. So we know which servers are capable to handle more queries than the others. So for instance, we know that the clusters are way over provisioned instead of the single instances. So if we have some sort of event, we try to put more far away the server that is under provision in comparison to the other one.
With prepending? With
prepending or with the BGP more specific route. So if we're having something like really happening in that server and we don't want that server to be involved, we will probably drop the /24, the most specific, and we will go to the /23 on IPv4 and stuff like that.
Yeah. So when you choose to deploy stuff, it's pretty much you want to have in different places and everywhere. The more the better.
Yeah.
All
the
right,
more
cool.
the merrier. Yeah.
Yes, while we're waiting for the mic to cue, Mauricio, could you just mention a little bit more about the /23 and the /24? Do all instances announce both?
Yeah, both instances announce both for IPv4, the /23 and /24, for IPv6, the /47 and /48. So the most specific route is supposed to be the one that what the client will prefer. So if we want to take out that instance, we will start not advertising the most specific one.
Alex May over Nicto DT. Can you outline like a little bit about the specs of the appliances that you're using, like small ones?
The smallest ones?
Yeah.
So it's one use server with redundancy hard drives, and we don't even have redundancy on power supplies outside of the box management thing. But it's a really small server.
So it's stock hardware essentially.
Yeah. They have some specific things in there, but yeah, it's very normal. Very useful.
Cool.
It's less than 2,000.
Okay.
With VAT and all the stuff are different things, but it will depend on the region. But the small one is going to be less than 2,000, and the bigger one is going to be probably around 10.
I suppose that with the smaller locations, you're only doing like a local announcement, or are you
No. We try to do global because we have a lot of deployment, so we don't have that many amounts of queries when we're deploying a new box. But if the host is struggling to do that, we would probably add some prepending there, so it won't have something like a big load, or we can use something else.
Thank you.
All right, thank you very much, Mauricio. All right, well, thank you, everyone. This is the end of the first session, and we have a break until 10:50. But before we take a break, I'd like to be sure to acknowledge our sponsor, Google. Google made a very generous contribution to help sponsor the ICANN DNS. Where are we? ICANN DNS Symposium. And so I'd just like to thank Google very much. And how about a round of applause for them, please? All right, so thank you very much, and we'll resume at 10:50.